Hi guys, it's Miss Keen here. Alright, I'm going to walk you guys through some selected problems from your probability study guide. We're not going to do all of the problems, but we'll do some from each part so that you guys can start getting the hang of it. We're going to start here with part 1, which is just calculating probabilities from singular events. We're only going to take a look now at scenario number 1. Alright, so take out your study guide. Hopefully you're looking at part 1 right here, scenario number 1. Alright, so scenario number 1 says, in a jar there are 4 red marbles, 6 green marbles, and 5 yellow marbles. Calculate the probability when choosing one marble. So before we can begin, if you guys remember from our previous videos, in order to calculate probability, you always have to know first the total amount you are picking from. So the first thing we need to figure out is how many total marbles we actually have here, because our probabilities are going to be out of this total number. All right, so we can do 4 plus 6 plus 5, and we find out that we have 15 total marbles. So as we keep going, there will be 15 total marbles that we're choosing out of. All right, let's begin. All right, problem number 1 says, what is the sample space when choosing marbles? Now, what usually confuses kids about sample space is they want to give me the how many. Sample space is literally just the what. What can I actually pick? When I'm picking from this sample space, when I'm picking from this thing of marbles, what am I actually allowed to pick? So our sample space is going to be the what. So first, if I stuck my hand in and I pulled out something, I could get a red marble. I could also get a green marble. And I could also get a yellow marble. Therefore, our sample space is just red, green, or yellow. I can't pull out a blue marble. There are none in there. Sample space, again, is just the what. What can I actually choose from this selection? All right, so now let's talk about calculating probabilities. So first, we're going to talk about number 2. What is the probability of choosing a red marble? So remember, when we're calculating probability is first what we want to pick. So we're going to go figure out how many total red marbles there are. So there are 4 total red marbles. And then it's out of how many we're picking from, which is our 15 total. So the probability of picking red is simply 4 out of 15. All right, what is the probability of choosing a green marble? Once again, we check and we see, okay, there are 6 green marbles. And that'll again be out of our total, 15 total marbles. All right, starting to get the hang of it, hopefully? Okay, let's try a combo color. Number 4 says, what is the probability of choosing a red or a green marble? Now, if you remember from our videos, since we're only picking it in one time, we're basically just saying, hey, add those 2 selections together. Because we can get a red one or we could get a green one. Either of those is totally fine for us. So we know that there are 4 red marbles and 6 green marbles. So when we combine them, we have a shot of getting 10 out of 15 because there are 10 marbles that satisfy red or green. All right, let's talk about our compound probability. So number 5 says, what is the probability of not choosing a red marble? So not, remember, not is called a compound. And our rule here is to get the compound, you take the total, you subtract the yes. So total minus yes gets us the no. So if our total is 15, our yes is how many red marbles there are, which is 4. We're going to do 15 minus 4, and we're going to get that there are 11 that are not a red marble. And then again, that's over our total 15. All right, let's try one last one. Again, we have another compound one. What is the probability of choosing red or yellow? So remember, that's when we add them together. So we have 4 red marbles plus our 5 yellow marbles, and together that means we have 9 out of 15. All right, hopefully you guys are doing okay so far. That is just part 1, scenario 1. I'll let you guys try scenario 2 out. So go ahead and pause this video and try scenario 2. All right, so hopefully you guys have now done scenario number 2 in part 1. Let's move on now to part 2, and I'm going to change my color for us. All right, so again, we're moving on to part 2. Oops, sorry guys. We're moving on to part 2. Part 2 is calculating probability of compound events. So the difference between part 1 and part 2, in part 1 I was just picking one marble. I was just saying, hey, here's one marble, I just want one, just see what the probability is, one try. Compound means I'm going to pick multiple times. I'm going to pick multiple times to get multiple marbles here. So the big difference here is you've got to pay attention to two key things. The wording will be with replacement or without replacement. With replacement means I pull a marble out, I say, actually, I don't want this one, and I put it back in the bag. This is an independent probability as nothing has changed. I took a marble out, I decided it wasn't the one I wanted, I put it back in, so our total is not altered. Versus saying without replacement. Without replacement says, I took the marble out, I liked that one, I kept it, and now I'm going for a second marble. Because I kept the first one, the total amount of marbles changed in my next pick. This is considered a dependent probability because one affects the other. So let's take a look at these. So again, we have the same scenario as before. So remember, we want to start out with saying how many total we have because it's hard to calculate probability without our total. So if there were 4 red marbles, 6 green marbles, and 5 yellow marbles, we had a total amount of 30. Ooh, not 30 marbles, wow. 15 marbles, guys, 15 marbles. All right, so again, our total is 15 marbles here. So let's check out the number 1. What is the probability of choosing a red, then a green with replacement? So a couple things coming into here. So first, we need to remember that our rule for compound events is that we're going to multiply their events together. So remember, there's going to be one probability for the first pick multiplied by the probability of the second pick, and that will get us our compound probability. Okay, let's talk about our picks first. All right, so first we're going to start with the first color, red. So what is the probability of choosing a red? So we know that there are 4 red marbles, and we begin with 15 total marbles. So our first probability is 4 out of 15. All right, here's where we then go to our second pick. Because it says these keywords with replacement, we know that the total is unchanged. It's going to stay as 15 because I took a red marble out, I said, actually, I don't want a red marble, and I put it back in the bag. That means I took one out, I said, no, I didn't want it, put it back in, and the total hasn't changed. But now we've changed colors. Now we're talking about green. So now there are 6 green to pick from. So this represents the probability of red, then green. So all we've got to do is we've got to multiply these two together. All right, so 4 times 6 gets us 24. 15 times 15 gets us 225. So our probability is 24 out of 225. All right, let's go to our next one. What is the probability of choosing red, then red with replacement? So again, our rule says it's the first one times the second one, and that'll get us our compound. So on our first pick, we're starting with red. So this is the very first pick. We know at the very beginning we have 4 red, and the total is 15 because that's how many we started with. All right, our second pick. So remember, it says with replacement, so that means our total is unchanged. It also means that I took a red one out, I looked at it, I put that red one back. So the red total has also not changed, so there's still 4 red in the bag. So this represents red, then red with replacement. So again, I'm just going to multiply across. 4 times 4 is 16. 15 times 15 is 225. All right, getting the hang of it? Let's do another one. What is the probability of choosing a yellow, then a green with replacement? So again, we're going to start with our green. So green has 6 out of 15 times our yellow. Yellow is going to be 5, and again, it's still going to be out of 15 because of that with replacement, which meant the total number didn't change. Multiply it across, and I get 30 out of 225. So as you can guys see here, in this first run, none of the totals have changed between the different problems. We had 15, we still had 15. We had 15, we still had 15. So when it's with replacement, the total number is not changing. That's keeping this independent. Let's talk about these same scenarios, but now without replacement. So number 4 says, what is the probability of choosing a red, then a green without replacement? So this is our trick here. it starts out the same way. So it's always our first one times our second one gets us our compound. That part has not changed. But let's talk about what does change. So first we're going to start with red. At the very beginning of this, I have 4 red, and I started out with 15 total. But what happens here is in the first pick, I get a red one, and I like that red one. I keep that red one. So what happens is, since I kept the first marble, the total has now decreased by 1. So on our next pick, it's going to be out of 14 because we removed a red marble. So on our next pick, when we go to pick green, well, there are still 6 green, but it is out of 14 total now because I have not replaced it. I took a marble out, I kept it, now I'm going back for a second one, and there's a lower total. So again, without replacement means that total is changing. One affects the other. This is a dependent probability. All right, we just need to multiply it across. So we've got 24 out of 210. All right, let's talk about number 5. What is the probability of choosing a red, then another red, without replacement? So what we've now learned is at the beginning, it's totally fine. We have 15 total. But after I remove one, the total goes down to 14. That's what we've just learned about without replacement. Without replacement meant that total went down. But here what we've got to also notice is that we are picking red, then another red. So here's what we're going to assume. On the first try, there were 4 red. But I'm going to assume that when I picked a red one, and I kept a red one. If I took a red one away, the red total is now going to go down to 3. So not only did our overall total change, but our red total also changed. So again, we're going to go ahead and we're going to multiply that together, and we're going to get 12 out of 210 as our compound probability. All right, hopefully you guys are getting the hang of this. Let's do one more for us. The probability of choosing a yellow, then a green, again, without replacement, which means our total is going to go down. So that means if I started at 15, I took one away, my next one will be out of 14. So first I'm picking out of 5 yellow. I get a yellow, I keep it. Now I've got 14 total. Now I'm going to pick, okay, there are 6 green, but now it's out of 14. So again, we're going to multiply that one together, and we're going to simply get 30 out of 210. All right, again, I want you guys to pause this video, try out scenario number 2 in part 2. All right, hopefully you guys have tried now scenario number 2 in part 2. Let's keep on moving. Let's move on to part 3. So again, you should be at part 3 right now. We're going to talk about Venn diagrams and probability on Venn diagrams. All right, again, we're only going to look at scenario number 1. Okay, so scenario number 1 says, in a class of 30 students, 15 students play soccer, 8 students play basketball, 3 students play both. Draw a Venn diagram representing the data. Find all the probabilities below. Okay, so let's first start by making our Venn diagram. So first, couple key things we need to know about our Venn diagram. First, we need to know about the total. So they told us that the total was 30. So that means everything represented inside this diagram has to add up to 30. If we add up to more than 30, or if we have less than 30, we forgot somebody. So let's talk about the parts of the Venn diagram. So the first thing we know is that this is comparing soccer and basketball. So one of these circles is going to represent soccer. The other circle is going to represent basketball. Okay? So then what else happens here is how that they relate to each other. This part in the middle, this is their both. This is the overlap. Those are the kids that play both sports. But then what always gets forgotten is this guy out here. This is the neither. Those are kids that don't play soccer. They don't play basketball. Maybe they play volleyball. Maybe they run track. Maybe they're in chess club. They're just not part of soccer or basketball. Okay? So now that we've got the pieces together, let's talk about the numbers. So the biggest mistake that students usually make is trying to right away say that there are 15 soccer players and 8 basketball. But the problem is those numbers include the both. So it's really important here that when you start making a Venn diagram, you always want to start with the both. We always want to put that both down here because there are 3 people that are represented in the number for soccer and in the number for basketball. And we want to make sure we don't end up double counting them. So when we're doing a Venn diagram, we always want to start with the both. We always want to start with the middle piece before we go to the totals. Because what's going to happen here is for soccer, this entire circle here, so this entire circle here needs to add up to the total number of soccer. This entire circle has to add up to 15. But we've already put down 3. So to figure out what goes left, we have to do 15 minus 3, and we're going to get the 12 that are left over here. That way we're not double counting the people that are part of the 3, because 12 plus 3 is 15, and there should be 15 total in that yellow circle. Same thing goes for basketball. This entire circle is basketball. So that entire circle has to be 8, but we've already got 3. So we've got to do 8 minus 3 and get our leftover of 5 out there. So this is why we always start with the middle, so that we don't double count students and we don't end up with more than we need. Okay, so here's the biggest mistake now that students make, is just saying, okay, I filled it in, the circles are full, let me move on. But we've forgotten about that outside guy, we've forgotten about that neither. To get the neither, we're going to go ahead and we're going to add up what we've got so far. So we've got 12 plus 3 plus 5. So far, we have represented a total of 20 people. The neither is what's left. So remember, if our total is 30, we can do 30 minus 20, gives us our 10 left over, our 10 neither. All right, now that we've got our total and our filled in, let's answer some probability problems. All right, so start with number 1. So this stands for, the P stands for probability, the probability of soccer. So remember, probability always has to be over the total. So our total here was 30. We know that there are 30 total kids represented. We've got to figure out how many are in soccer. So remember, look above. Soccer was represented by what I did right here in this yellow circle. This entire circle was soccer, not just the 12. So the entire circle is 12 plus 13. So there were 15 out of 30 that played soccer. All right, next we've got P, again, that stands for probability soccer, but then we've got this little C. That little C right there stands for not. So this is the probability that they're not in soccer. So remember what I said a few slides ago. To figure out the not, you take the total minus the yes, always gets you the no. So in our case, what we're going to do is we're going to do the total, which is 30, minus the yes, which we just found is 15. So when we do 30 minus 15, we end up figuring out that there are 15 in the no, and then our probability is always out of the total. So this basically means that half play soccer and half do not play soccer. All right, so let's keep going. All right, so this one, number 3, says probability of soccer and then N basketball. Remember, this N stands for the and. And is the overlap. And is where they are both happening at the exact same time. So I want you guys to take a look at the picture and notice, okay, where is the overlap? Where are they happening at the exact same time? Notice where I've highlighted there, that both is the and. So there are 3 people who do soccer and basketball, and again, that's out of our total, which is 30. All right. Our next one's the weirdest one. This is soccer U basketball. That U stands for our or. So this is everybody that's included in the soccer section, everybody that's included in the basketball section, and, everybody that's included in the both. So this includes the soccer part, this includes the both part, this includes the basketball part. So all together, we get 12 plus 3 plus 5, and there are 20 people represented in all of those choices. Again, out of our 30. All right, let's talk about this next one. Number 5 actually means the same thing as number 2. So number 2, we had the little C that stood for not. In this one, we have the bar, which stands for not. So this is asking about all of the kids that are not in soccer, not in basketball, not in both. So remember, to get our not, we always do the total minus the yes equals the no. So again, if you remember from our last one, our total was 30, minus our yes, which we found in number 4, was 20, and what's left is 10. And that is always out of our total, so it is 10 out of 30. All right, guys, so Venn diagrams are probably one of the most tricky things we are learning in probability because there's a lot going on here. So it's helpful to kind of color them in and help yourself out. All right, go ahead and try scenario number 2 on your own. Pause this video, try scenario number 2. All right, guys, let's talk about the very last section, part 4. All right, part 4 deals with everything kind of all at once, but on a two-way table. Two-way tables are really nice because Venn diagrams can only really show you a certain limited amount of things relating to each other, and two-way tables can tell you a lot more. So let's just start with finding simple probabilities of two-way tables. So remember, first thing you need to know when you're finding probabilities is that overall total. On a two-way table, that overall total is always represented in that bottom right-hand corner. So our probabilities right now are going to be out of 150 because that's our overall total. So section 1 is just about finding the probabilities of columns and rows. So if this says find the probability, so it says find the probability of an A. So what we would do is we would go to our A row and we just find the total. So the total number of A's is 31, and that's always out of our overall total, which we said was 150. So the probability that somebody got an A was 31 out of 150. Same thing with our C's. If we want to know the probability of finding a C, we go to the C row, we find the total number of C's. Okay, there are 38 out of 150. Not too bad, right? All right, so let's move on then to section 2, finding complements. So remember, complement is the same as saying not. It's the same as saying no. Now, I've been saying it in this whole video, but to do that, it is the total minus yes gets you the no. So if we are talking about the probability of not an A, we would do the total, which was 150, minus the A's, which we found in part 1, which is 31. So if we do 150 minus 31, we figure out there are 119 people who did not get an A, and that's always out of our total, which is 150. All right, let's talk about not a C. So remember, it is, again, the total, 150, minus the amount of people who got a C, which we showed was 38. So 150 minus 38 is 112, and again, out of our total, 150. So again, for a brief second, let's talk about what these mean. So in part 1, this just represents how many people got an A. So out of the overall total, 31 people out of 150 got an A, versus the complement, which is those people who did not get an A. So this is 119 people did not get an A. Together, they should add up to your total. So you plus your complement should always add up to the total. So if we double check, 31 plus 119 does indeed equal 150, which means that works. That totally works. Those are complementary events. Okay, so reading the probabilities and finding the complements, not as bad. It's when we start talking about the intersections, the unions, and the conditional that it gets a little bit confusing. So let's check out our next sections. All right, first let's talk about the intersections. So an intersection is an overlap, y'all. An intersection is where both things happen at the same time. So remember, for example, this says A and study. This means somebody that got an A and they studied. It means they have to have done both things. The reason why we call this an overlap is it's because it's actually where events overlap. So what I would do is I'd find first the A column. So I'm going to go up here and I'm going to highlight there the A column. Okay, so everything in there is represented in the A column. Now I'm going to go to the studied row, and I'm going to, okay, everything in here is studied. The and is where those overlapped. So take a look right here where they met, where they intersected, where they overlapped. That's the number we're looking for. That represents that there are 24 people that got an A and they studied. So there are 24 people represented in this overlap, and then to represent the probability, it's always over our total, which if you remember from our last section, was that 150. So this represents that 24 students out of 150 both got an A and they studied. So again, our intersection is our overlap. It's where those columns and rows overlap. It's just that little number that happens at the exact same time. Versus a union. So look at part 4 here. A union's a little bit trickier. So a union is OR, and a union includes a whole lot more than an intersection. An intersection is always a much smaller number than a union. Unions are a lot harder to see on a two-way table than they were on a Venn diagram, which is why we have a rule. It's called the addition rule. So whenever we're trying to find an OR, we're going to use the addition rule. The addition rule says this. It says the probability of A or B, so that's what we're trying to find, is equal to the probability of A plus the probability of B plus the probability of A and B. So basically, it's the total in the A plus the total in the B plus that overlap. So let's take a look here. If we are doing the probability of A or studied, we first need the probability of A. So our A total here was 31. So it'll be 31 plus the probability of B, which is studied. So studied total was 66. So 31 plus 66. But we just double counted our overlap, so we have to minus that and that overlap that we just found, which was 24. So we do 31 plus 66 minus 24, and we end up with 73 people are in that OR, and always that's over our 150. You guys want to see one more? All right, I'm going to erase some things so that this doesn't get super busy for us, but let's check out the next one. Let me erase my work up here so we can see some stuff. Okay, so again, let's see this one more time. If we're talking about F or did not study, first we need the probability of F. So we need to know how many F's there are. So if I go to the F column, there are 53 F's. Plus the second thing, how many did not study? So I got a did not study, and the total is 84. So it's 53 plus 84. Then I need to subtract their overlap. So remember, we're talking about our F. We're talking about our did not study. And we can see where I just overlapped right here was that 47. So minus 47. So we do 53, which is F's, plus 84, which is did not study, minus 47, which is the and we get 90. And that's always out of our total of our 150. Okay, unions can be a little bit confusing, okay? They definitely have the most going on. They end up using all of the other probabilities. So they use the normal probability. They use the and to find that or. All right, the very last probability we have to talk about is the conditional. So I'm going to, again, erase my entire thing above because conditional is one that we often struggle a lot. So here's the weirdest thing about conditional. Conditional is the only probability type that isn't out of the total. So conditional is what we say when something is given. The probability of A given studied. So what this means is it's asking, what is the probability a student got an A given that they studied? This is asking us, do we already know something happened? So what happens here is there is a formula. The probability of A given B is equal to the probability of A and B out of the probability of the thing we already know, which is always listed second, which is B. Okay, so what we're going to do here for our first one right here, for number 5, the probability of A given studied. First and foremost, this is not going to be out of the total. This is going to be out of how many people studied. So we're going to go figure out how many total people studied. Well, 66 total people studied. That's what's going to be on the bottom. So the bottom piece is always the one we already know. What goes on top then is that overlap I showed you. So it's the overlap of A, so here's our A row, and studied. And as we've seen in our last couple examples, that overlap right there is what happens twice, and that's 24. So what often throws students off about this one is because we didn't use the real total. We used new numbers. So the thing on the bottom is the second thing listed, it's the given thing. And what's on the top is their and, is their overlap. All right, guys, there were a lot on this section that we did not do. I want you guys to go ahead and try those last sections together, and you guys are good to go.